In this video, I will share a brief overview of the lesson, How Do You Start? How Do You Change? This lesson is found in Unit 6, Graphing and Analyzing Exponential Functions. It is the 5th lesson of Unit 6, and it is a 2-day lesson. In this lesson, students are expected to write an exponential function, analyze exponential growth decay functions, calculate the result of applying a percent increase repeatedly, and write the result as a numerical value and expression, use graphs to illustrate and compare situations in which different percent increases are applied to the same initial value, write a numerical expression or an algebraic expression to represent the result of applying a percent increase repeatedly. The standards covered in this lesson are standards 4, 5, 6, 14, 25, 27, 28, 29, 30. We will take a closer look at standards 5 and standards 6. Students will have several opportunities to practice creating and analyzing exponential growth and decay functions. In this lesson, students will see how to represent compound interest with an exponential expression. They need to realize that the process of repeatedly applying, say, 5% interest n times is the same as multiplying by the quantity 1.05 raised to the nth power. So the lesson begins with students deriving that formula. So to begin with, Alex invests $250 and each year she gets 4% growth on her account. How much money does she receive after 1 year? So her initial amount is $250 and the amount of interest that she's going to earn is 4%. So here we can see that she's going to have 100% of the $250 plus she's going to get 4% of $250. So the expression to see how much she will have at the end of year 1 would be the $250, which here you can see that that is the common factor. So that's why we can factor that out. And what we are left with is that 1 plus the 4%, which becomes 1.04. So on year 2, she's going to have all of what she ended year 1 with, which was this 250 times 1.04, plus she's going to earn 4% interest on that year 1 end amount. So as you can see, the common factor is the 250 times 1.04. So if we factor out that piece, what we were left with, so that is our common factor, so that comes first, and then what we have left when we divide this would be the 1, and then when we divide this would be the 0.04. As you can see, these are equivalent expressions, so we have 1.04 times the 1.04, so we can rewrite that expression as 250 times 1.04, that quantity squared. So how much money does she have after 3 years? If we continue that process, she would have the 250 times the 1.04 quantity squared, plus we would take 4% of that amount. And so we would end up in the end with 250 times 1.04 to the third power. So the purpose of having students write that out several times is so that they can learn how to derive a general equation that would describe exponential growth by R% over a t time period. Here, it might be a good idea to have kids practice how to convert a percent to a decimal, just so that when they are writing their equation, they're writing it correctly. On number 7, you're introduced to kind of the opposite, and that's a decrease, so a decay, and the value decreased by 15% each year. So after this, you can have students write a general equation that would describe exponential decay by R% over a t time period. And I would show them that it could be written both ways, where you could show the amount of decay inside the parentheses, as well as show what percent would be remaining. So for number 7, they could write it as either 1 minus 0.15 to show that it's a 15% decrease, or they could write it as a 0.85 to show that the car's value is at 85%. So in your independent time, you will work numbers 1 through 7. And then I would like for you to choose 2 problems from 12 to 17 to work as well. As you are working, pay close attention to the structure of the equation. And as you are working, anticipate what types of errors students could potentially make and how you will provide support.